Hello, and welcome to another Into the Terminal. Today we're going to be talking about Logical Volume Manager and troubleshooting it. So let's just jump right into the terminal. So to start off with, in these episodes, we're taking a look at our toolbox to start off with, right, as part of our critical path. So when we're talking about Logical Volume Manager, there's really three different abstraction layers between the devices and your data that you're storing in the file system. And so there is the physical layer, which you can look at with PVS. So I have one physical volume, one disk device that's part of my logical volume manager setup at the moment. It's dev SDA2. We can look at the volume groups that are stored across these physical volumes with VGS. So I have one volume group called RHEL, um, and a little bit of data there. And then we also have LVS to show you the logical volumes stored within it. So I have two logical volumes stored inside that volume group, which is held on that one disk device. That logical volume list is the root logical volume and a swap space logical volume. So PVS, VGS, and LVS, those are three very quick and simple commands to get you going. But there's some longer data commands too. So especially as we start talking troubleshooting, knowing more about these devices is key. So we have pvdisplay. So it'll tell you the physical volume's device name, the volume group which it belongs to, the physical extent size. So that's how much disk space is individually allocatable on this physical volume. So we can allocate as small as 4 megabytes to a logical volume. The total physical extents. So on this device, which is about 19 gigs, we have 4,863 extents. Free physical extents, none of them are currently free. They're all used. And allocated, they're all currently allocated. All right, just like we had three other commands that talked about physical volume, logical volume, and volume group, same thing is true for the displays. So we have a vgdisplay. So our one volume group, which is called RHEL, is an LVM2 formatted volume group. It currently has two logical volumes. That's what cur LV means. They're open, meaning they're currently in use. There is one physical volume, right? Cur PV and act PV, current and active physical volumes. Our overall disk size is about 19 gigs. Our physical extent size, which is also reported in the physical volume information, is 4 meg. And then we get a little bit of usage data. All right, and likewise, we also have LV display. So we have two logical volumes. The first one is a swap logical volume, which is being used for swap space for this machine. It's currently 2 gig, right? LV size, 2 gig. And then down under dev rel root, that's the root logical volume, has all the rest of the disk space for this machine, and it's about 17 gig. All right, one other thing I'd like to call your attention to is in both of these, you have an item called segments. And that's going to be important later. That's contiguous blocks of disk storage that's used to store this logical volume. All right, so the VS, right? PVS, VGS, LVS, real quick, simple one-line outputs or a couple lines outputs, summary information. The displays, a lot more information about how the disk space is being used and what component devices and other stuff are in it. But you may have started to sense a theme. So it turns out that there's a whole bunch of PV something commands, right? PVS we saw, PV display we saw. We're going to maybe take a look at PV move today as well. We're also going to use PV create. So these are the physical volume manipulation commands in volume groups. There's also a vgextend. something. So these are dealing with your volume group that is made up of physical volumes. These are the things you can do to it. And so we're going to be VG extending today. Um, we will possibly be doing a VG reduce today. We'll see if time allows. All right. And just like there's a PV something and a VG something, well, guess what? There's also an LV something. So we're going to be taking a look at lvextend today for sure. We'll also be looking at um, maybe lvcreate. We'll see again if time allows. So there's a whole bunch of logical volume commands that kind of build out your toolbox for working with logical volume management on RHEL. All right, so that's the critical path. What's our toolbox? These commands to control physical volume level stuff, volume group level stuff, and logical volume level stuff. After the transition, we're going to do a little bit of whiteboarding so we can actually like see how this all kind of ties together. And then we'll get into the actual like troubleshooting and fixing things. So don't forget to like and subscribe, and we will see you right after this. All right, so you may have noticed that I'm on my own today. Nate is at meetings. Lucky Nate. Um, so we're going to take a look at kind of how things work in volume management. And you'll recall that earlier in the series of troubleshooting, I said something like, my friend who's an ops wizard used to say, hey, if you don't understand how things work and what it's supposed to look like, how are you going to troubleshoot it when things go wrong? Or how are you going to know what to do when things aren't working right? So let's take a look at our whiteboard. And I've already preceded it with a little bit of content. So this is what my machine currently looks like. I have devsda, which is the primary disk for this machine, and I have devsdb, which is partitioned, but there's nothing stored on it yet. All right, on devsda, there's a small, like 1 gig size boot partition that's a standalone file system. And then what we saw in the critical path was we were looking at our volume group, and it said there's one physical volume, devsda2, and then when we looked at devsda2 is actually being used to store two different things. So it kind of looks like this, where what I'm putting in yellow, orange, I guess is a better description of this color. That is dev rel root. That's all my file system information for this machine currently. And then there was also down here in green, that was my 2 gig of swap space. Oops, should be an uppercase G. So that's what my disk storage currently looks like. And give me 1 second, because I'm going to introduce a problem on the storage. There we go. Um, and what we're really doing in this like logical volume setup is I'm using a single physical device, that partition devsta2, and I'm then reallocating portions of its space to these additional meta devices. So you can see that the device file name is /dev, the volume group name. So my volume group is called RHEL. I took the default partitioning scheme when I installed this machine. So that's what we got. And then it created two logical volumes underneath of that volume group, root, which is all the file system stuff, and swap, which was the swap device for this machine. So I just installed Linux and just took all the defaults for the partition format, and this is kind of what came out. All right, so What's really cool about this is that I can store multiple things in the same disk device. So the other thing I've got on this machine is I added a second disk device, devsdb. And I went ahead and created a couple of partitions on it. devsdb1, which is 5 gigs, devsdb2, which is 5 gigs, and devsdb3, which is 10 gigs. And what's really awesome is that with logical volume management, you can actually tie together multiple devices into a single addressable disk space. And so I can take these different sized partitions, or maybe even whole disks, and I can lump them in as physical volumes to our volume group. So we're going to change back over to the terminal. I'm going to show you an example of what this looks like. We're going to go through the process to actually add more space to our volume group and our file systems. And then we'll flip back to the whiteboard and talk about what did we really do with that. All right. So in many shows, we've talked about like finding big files and figuring out what you can delete to not be disk full. And you'll notice that this machine is currently 100% full on its slash file system. Not where you want to be. And in the past, we would like try to find what was using the space. But here in logical volume management world, I have this extra disk, devsdb, and I've got some extra empty partitions on it. So why don't we just add more disk space to our disk and call it good? So what we're going to do is I'm going to just show you what I have here. So I've got 3 partitions on devsdb. SDB1 is 5 gig, devsdb2 is 5 gig, and devsdb3 is 10 gig. And what I need to do to add this to my volume group is I first need to pvcreate one of these partitions. So I'm going to pvcreate devsdb1. All right, now what this pvcreate step does is it writes out a little bit of formatting information to this file or to this partition that says that it can now be used in logical volume management. But if I look at its pvdisplay, dev sd, try that again. Interesting. Well, it let me successfully create it. Let's see if I pvs. Okay, so maybe because it's not allocated, it's giving me an error there. So I'm going to do a vgextend. Actually, I'll just say RHEL. So I want to extend my RHEL volume group to include devsdb1. Interesting. Oh, you know what it is? Because my disk is full. 1 second. Man, when your disk is completely full, weird things happen, like you can't do stuff anymore. All right, so let me try this one more time. pvdisplay. Okay, there we go. That's what I was looking to do. So my physical volume there is devsdb1. Because my disk was full, I was having problems writing additional metadata into things because I filled it up completely with like 0 free space. That was silly of me. Um, Notice that its physical volume size is 5 gig, right? I said it was a 5 gig partition, and it is not currently allocatable. So even though I have that 5 gig there, I can't use it in any of my volume group setup. So I'm going to do a vgextend on the RHEL volume group to add devsdb1. All right, so now it's successfully extended. So if I do a vgdisplay, there's my RHEL volume group. And notice that down here, this has changed. Its current physical volumes, it was one because it only had devsda2 before, and now has two active physical volumes. The other thing to note is this. So before we did this extend, this volume group was 19 gig in size, more or less. And so now I've added another 5 gig of disk space, and it's about 24 gig in size. All right, so now I have more addressable space. And let me fill up my file system one more time. There we go. So let's take a moment. Um, and we have not tagged this space yet. So while that space is available in the volume group, it doesn't belong to either one of these logical volumes that exist, nor have I created an additional logical volume to consume this extra 5 gigs of disk space. And I wonder if I'm going to run into the same problem when I try to logical volume extend it. We'll see. Hey, you know what? I just won't use all the space. How about that? That'd be smart of me. So I used 7 gigs of space. Let's see what we got here. DFHP. All right, so we're at 70% usage. That's good. Enough that I can actually use metadata and update files and stuff, but not so much that the machine comes to a crashing halt. All right, so you can see that my file system here is 17 gig in size. That's my root file system. And if I do a LVs, right, we're looking at this guy, right? So 17 gigs of disk space allocated to this logical volume. And then the file system is 17 gigs, right? Because it goes over that entire amount of disk space. So I'm going to add this 5 gig that we added to our volume group to this logical volume. So I'm going to lvextend plus 5 gig dev rel root. All right, fine. You're rounding, and I don't want you to round, so we're just going to say 1279. There we go. So when you get the math right, it extends. And it added 1,279 extents, which is about 5 gigs of disk space to my logical volume, right? So if I do an LVS, right, so there it is. I think I added incorrectly. I only added 1.25 gig. So let's do, all right, let's try that. All right, so that looks a little better. So I've added a bunch of space. I added about 4.25 gig to this logical volume. And if I do a df-h, notice that while my device is 21.25 gig, the file system is only 17 gig still. So while I allocated more disk space, I didn't resize the file system to consume that extra space. So I'm going to xfs growfs dev rel root, and that resizes my file system to include that space that I just added onto it. And now if I df-h, notice I went from 70% used to 56% used. I also went from 17 gig of total space to 22 gig of total space. And there we go. So I've successfully added more disk space to my file system. All right, so let's flip back over to the whiteboard and we'll talk about what we did with all those steps. All right, so uh, this is what we were like in the beginning. And I used all of that orange hash marked disk space, right? That was 17 gigs of disk space. I used it all up or used a bunch of it up and I needed more. So what we did is we went over to DevSDB, which is a 5 gig device. And the first thing we ran on it was pvcreate. And pvcreate put this little bit of information, you can see it's a little tiny information into the device. So when we did a PV display and it told me what volume group was associated with, what the physical extent size was, whether it's allocatable or not, there was also a space that was blank in there for a UUID number. All that metadata goes in this little tiny little bit of space that goes into the physical volume when we run PV create. So this area is called a volume group descriptor area, or VGDA. It's a silly name, but it's basically just a spot where we can store information about this device. All right, then we did a vgextend so that this space is now included in my dev.rel volume group. Right, and what that really did was it cut all this space up into allocatable disk space, which in our tools were described as physical extents. So if we were to look back at the text in our terminal, we would see that each one of these little blocks is 4 megabytes of disk space, and that's the allocatable unit of disk space inside our volume group. And then what we did was we did an lvextend. So I did an lvextend on dev.rel root and added another 4.5 gig of disk space. And so really what we did was we added this into this device. So now we have disk space able to be stored between both of these physical volumes, these physical devices. And that's why when we added the space together, it was 24 gigs in size now because we added more disk space to it. And then the last thing we did is, even though we had extended our logical volume to account for this space, it had not been formatted with our file system. So if we were to look at the file system data, it said that it was 17 gigs in size. And so we had to use the XFS growfs command to actually push that file system format across all of this space down here so that we could store files and directories down there because it now has the same file system format as our device up on DevSDA. All right, and then I didn't use up all the free space on DevSDB1. So notice down here, there's some unallocated extents. Those are free, and we could allocate them to this file system. We could allocate them to our swap space. We could create a new logical volume out of them and use it to store additional files and directories for something else. And then we have these two unused partitions. Right, so that's our current setup on this machine. So let's flip back to the terminal and we'll take a look at some other changes that have happened on the machine. All right, so early in the episode, we did a VG display, and there was our volume group information. And what has changed is down here, our allocated physical extents, once we added that second partition of disk space, we got some more free extents. And you can see that there's still about 764 megs of unused space. That was that like little sliver at the bottom of my partition. The other thing that's changed is if we do a LV display on dev.rel root. So I grew this file system and this logical volume together to take up that additional space. And the other thing that has changed is this. So before, it had been stored in one segment, one contiguous block of extents inside of our volume group. But now it's stored across multiple devices because there are some extents on devsda and some extents on devsdb that are being used to store this logical volume. And so you can see as you increase the disk space associated with your volume group and start to span more physical devices, you'll have more of these segments as you span the devices. All right, so let me talk about another thing that we might be interested in doing with logical volume management. So let's say that we're interested in phasing out one of our devices that is a component of our volume group. So if we do a pvs, devsdb1, we don't want to use devsdb1 anymore. Maybe the disk is too small and we've replaced it with a larger disk. In fact, let's do that. So pvcreate devsdb3, vgextend. All right, so we now have 3 active physical volumes, and I added that third partition on my second disk, which is 10 gigs. So that's why we went from 23 gigs to 33 gigs. But the whole goal of doing this is I want to get rid of that 5 gig partition that I added earlier as a physical volume. So there's a command called pvmove, and it can be run live while the system is active and the file system is active. And what it's doing is it's looking at each one of those extents in dev sdb1 and it's copying them to other available extents within my volume group. And since the space that I have that's available is on dev sdb3, basically took all the content that was currently in use on dev sdb1 and copied it all into dev sdb3. So if I do a pvdisplay devsdb3, right? So it's allocated 1088 of those 4 megabyte blocks of storage. And if I do a PV display on devsdb1, right, those 1088 blocks were actually copied from this device, devsdb1, into the other component devices of our volume group. And now if we look at it, its allocated physical extents is 0. There is no volume group storage currently residing on this device. All right, so now I've moved all the data off and I can go about removing this device from my volume group and setup. So when we're adding new devices, we did a pvcreate to put the volume group descriptor area down on the device. Then we did a vgextend to add the device to our volume group. And then we started allocating the space on it. So we want to do the opposite direction now. So we use pvmove to take all the existing space and move it to other places. And now we want to do a vgreduce to remove this physical volume from our volume group. All right, so when I look at the volume group after I've removed this device, I should see that it has roughly 5 gig less space. So if I do a vgs, so we were at 33 gig and now we're at, or maybe 34 gig and now we're down at 29 gig, right? So that 5 gig of space was removed. And if I do a PV display on dev SDB1 right before it was part of the RHEL volume group, and it was allocatable, but none of the extents were in use. And now notice that it no longer has a volume group name, right? It's just out there, not being used by any volume group. And none of its space is currently allocatable as physical extents. So I've removed that device from my volume group setup. And now I can retire it, right? So I could do a pv remove devstd1. And so this wipes off that logical volume or volume group descriptor area from it. And now I can disconnect this device from my machine and no one will miss it. All right, so let's flip back over to the whiteboard and see what did we really do there. All right, so to start off with, we PV created devsdb3. That put down the volume group descriptor area in it. Then we VG extended into devsdb3, which then added it to our RHEL volume group and divided its disk space up into these allocatable units called physical extents. All right, then we did a PV move. And the PV move took all the space from up here in devsdb1 and copied it down to devsdb3. So it looked like this. And when it made that copy, it went ahead and not storing any logical volume data there anymore, right? But it was still allocated. Whoa, that's big. It was still allocated to our volume group. So we still had these blank allocatable physical extents, all right? But they were unused. And then we did a vgreduce and removed that volume from our volume group. So it wasn't our volume group anymore, but it still had our friendly neighborhood volume group descriptor area there so that we could add it to another volume group or reuse it if we wanted. So then we used pv remove, wipe that out. And we were left with just a blank unallocated partition that I can't draw in our disk layout, right? And let me go ahead and just kind of fix this up here. Because now our logical volume was instead using 4.5 gigs or whatever it was down here out of devsdb3 in order to congregate together its 24 gig of disk space. So that's kind of what we did with the first PV move to copy all the data to our other replacement disk device. And then we VG reduced it to remove the volume, the physical volume from our volume group. And then we did a PV remove to actually remove that volume group descriptor area. Now that PV remove is actually a really critical step because if we forget, it turns out that we've logged the physical volumes that are attached to our machine in some metadata files. And if we disconnect the disk device, the next time we boot the machine and we're trying to reconstitute together all of our volume group layout, it'll still look for that device and you'll see some errors appear that it couldn't find a device with that UUID anymore attached to the system. And getting rid of it at that point is kind of a pain. So if you account for it in the future, you're disconnecting the device, you're going to go ahead and remove it and remove its volume group descriptor area so that nothing is ever looking for it again. That's what you want to do so that we kind of clean up some of this metadata that gets stored about volume groups. All right. So that's moving to a new device or decommissioning a disk device. So let's take a look at the chat and see what we've got over here in chat. It looks like it's just a lot of back and forth about using LVM on other file systems. So I see that Rick Green said about HP LVM, and turns out that that implementation of LVM was used as the basis for Linux LVM and the device mapper. Um, yeah, so I think that's pretty much what was asked. All right. Um, let's see. Should we create another volume group or a logical volume rather? Let's do that. All right. So I've got all this space. If I look at vgdisplay, I've got some extra space, about 5 gig of free space. So we can also create new file systems and new devices using this free volume group space. So I can do a lvcreate. I have to give it a name. I'm going to give it a very uninventive name of data. And we have to tell it how much to allocate. So we're going to do 4 gig. All right. So it created a logical volume called data. It created that within the RHEL volume group. And if we look at a VG display, so we can see that we now have 3 logical volumes created. Only 2 of them are active because we haven't used this one yet. And then we could see that our free physical extent or free space went down because I allocated a bunch to this logical volume. All right, so I went out and I like grabbed a bunch of those physical extents and I isolated them together and assigned a device file to them. But right now it's just raw, unformatted disk space. So the other thing I'm going to do is I'm going to make a file system of it. So I made it a XFS file system, and now it's got a correct format. And let's go ahead and mount it. So I created a mount point called slash data, and I mounted it. And if we look at df-h, right there it is, right? Roughly 4 gig, which is what I told it to create. We formatted it. Now I can put files in it. All right, so let's go over to whiteboard. What did I just do? All right, so when I did my LV create, what I did was I went out and I grabbed 4 gigs of this unassigned physical extents that were part of this volume group. Right, so I allocated all this to space. And there's a little bit left. See down there at the bottom, there's a little sliver left of unused disk space that's still available to the volume group. And then what I did when I created that LV create command is I said I wanted 4 gigs of space, and I also gave it a name. And that name created dev volume group name, the name that I supplied in my LV create. And then I formatted this selection of disk space as an XFS file system, and I mounted it, right? So that's what I just did with that LV create, and the format and the mount was allocated this disk space, formatted it, and then attached it to my machine so I could store files in this little segment of disk space. All right, so that's a little bit on logical volume management. I think that the key things to be aware of is there's the 3 layers right? There's the physical layer. What disk devices are making up your um, logical volume management infrastructure? There's the volume group layer, where you're taking devices and you're tying them together into a meta device called a volume group. And that can span physical devices. The third thing is you make a logical volume. A logical volume is how you then claim portions of that volume group space to store file systems or other stuff. So that's where we did the LV extend to grow one that exists to grab onto more space, or the LV create to make a new logical volume to grab onto that disk space that's part of our volume group. And then the other thing we did was we had to work with the file system format. So just because you add disk space doesn't mean it's formatted. So we had to use tools like XFS GrowFS to push that file system into our newly allocated space to our existing um, logical volume and file system space, or we had to use mkfs to take a new file system and lay it down on this newly allocated logical volume that we created just a minute ago with data. The things to keep aware of on this is what devices are components of your volume group, right? So what physical devices are components? And we talked about how if you need to retire a disk, you can actually move all the in-use stuff off of it using pvmove, and then go through and remove it from the volume group and wipe out the volume group descriptor area on it so that you can remove it from your system. Um, the key thing there is that each one of the components in your volume group has a unique ID, a UUID assigned to it. And that UUID for each component is actually tracked in a bunch of configuration data. So if you disconnect those things from your machine, but the configuration data still exists, you'll end up at boot time getting a bunch of error messages about not being able to find these component devices that the system expected to be there but are no longer there. And so that's why we use commands like pvremove to actually delete that from our configuration metadata so that we could completely disconnect the device and not have any leftover data associated with it on our machine, right? So um, just be aware of those types of things when you're working with logical volumes. Realize that you're building this kind of amalgamation of different devices that you're then going to store files and directories on. All right, one other question I get asked a lot. So because we're creating this meta device of other component devices, and even a meta device of that with physical extents, trying to figure out what portions of those different devices we're actually storing data on. People often ask me, is Logical Volume Manager slower than like straight disk partitions? And on the surface, like if we look at the extra work that's being done, yes, we have to look at the metadata that's there and figure out like where we're storing things in physical extent sizes. We're doing file system operations and other stuff. So there is more overhead in doing all of these disk device things. If you look at the flow and the procedure for working with this thing. So intellectually, we know that it's more challenging and takes more compute time to do. But the reality is, it's not perceivable to processes or people. So, what we gain with logical volume management is all this extra flexibility of being able to slap devices on after the fact and grow our file systems and then shrink stuff and move our disks around to other places. We get all that flexibility for no perceivable reduction of service. And that goes true for things like benchmarking too. Benchmarking really doesn't show any perceivable degradation of service going onto partition formatted file systems versus logical volume managed file systems. So you gain flexibility, and yes, intellectually, we know that there's more work being done there by the kernel and the system, but practically, it's imperceivable to us and our processes. So I wouldn't worry about that and would instead enjoy the flexibility that LVM provides you. All right. So next steps. Um, hey, why don't you try one of our hands-on labs at lab.redhat.com? We don't have any LVM ones there. Maybe I should fix that. But we do have a whole bunch on container management, um, doing leap upgrades, doing convert to RHELs from other similar to RHEL Linuxes to make them actually RHEL, um, adding extended update support so you can stay on a minor release longer for RHEL. We have all kinds of hands-on labs at lab.redhat.com. Why don't you try them out if you've not done it before? All right, what's coming up? Next week, RHEL Presents. We're going to be talking with Yubico and talking about YubiKey support in RHEL, which is pretty slick for things like single sign-on and multi-factor authentication. And then here on into the terminal, next week we will be talking about networking and looking at some troubleshooting of networking. But again, same idea. We're going to start off with our toolkit, and then we're going to talk about like what is actually happening when we're doing stuff, and then we'll introduce some errors and troubleshoot them, or some activities and perform them. All right, till next week. Great to see you again. Thanks for attending into the terminal. If you're a deferred viewer, please feel free to leave us a comment. Don't forget to mash that like and subscribe. See you all later.